Okay, in this video I'm going to define a horizontal curve, and this is usually used, in surveying, only in surveying, but some civil engineers use it too. Picture this diamond thing you're looking at here as flat on the ground and on a plane that's that's perpendicular to a line going straight up from where you are. So a plane perpendicular to the line, of where you are. So say this is the Earth's surface, right? This curve is going to be on a plane that just touches the surface of the Earth where you are, and zenith would be straight up, like straight up, perpendicular, or orthogonal, or normal to this plane here. That's where you are on the Earth's surface. Because surveyors usually measure on a plane. Okay, so this is a horizontal curve. There's many parts to it. I'm going to start naming these parts. There is a PC. PC is the point of curvature. PC is equal to the point of curvature. Point of curvature. PT is the point of tangency. The point of tangency. Point of tangency. All right, so it's kind of, it's like a circle. This is part of a circle. You're going along a road. It's a straight road, and when the curve begins, that's called your PC, and where it ends, that's called your PT. If you start going back along a straight away on the road. So it's tangent, right? It's tangent, the point of tangency. The curve is tangent to this line right at the PC and the PT, the same thing. All right, T is your tangent. T is your tangent. That's the distance from your PC to your PI. It's the same thing as your PI to your PT. Same distance. That's equal to the tangent. They call it a tangent. All right, R is equal to the radius. Whoops. The radius of the curve. Radius of the curve. PI is the point of intersection. Point of intersection. CC, right? CC is the curve center. This is delta, right? This symbol is equal to delta. Right? That's the angle subtended by a certain amount of arc. Right? It's the angle subtended by a certain amount of arc. And I'll define arc as A right now. A is arc. Is the arc of your curve. It's also called sometimes the length. The length as well. All right. E is your external. External. That's the distance from the PI to a point on the curve halfway, halfway along the arc. M is the mid-ordinate. and I'm doing my best to write lowercase here. It's tough for me. C, right? C is this distance from your PC to your PT, the straight line distance from your PC to your PT. That's the chord, right? PC to PT. Chord. You sometimes hear the chord of a circle. This is a chord of a circle right here. This distance right here. What else am I missing? Okay, this angle here between, from the PC to the PI, the angle between that and the chord is always delta over 2. It's going to be delta over 2. The long chord. Sometimes this is called the long chord. Right? Long chord. Long chord. So, that, I just defined this horizontal curve. And a lot of, if you're surveying, you're going to be dealing with this horizontal curve a lot. So you want to get yourself familiar with the parts, and in another video, the next video, I'm gonna teach you how to calculate points, all these different parts of the curve. I'm gonna teach you how to solve those. And to know everything about a curve, you need to know two parts. Need to know two parts. To solve the curve. To solve for everything on the curve, you need at least two parts. Usually a plan will give you two parts of the curve so you can solve for everything else. It'll give you the radius and the delta. Sometimes they'll give you three parts just to make sure that one thing isn't on the plan wrong, or something like that. So you need to know two parts. And usually you give it a definition of degree of curvature, the degree of curvature. You'll hear about this a lot, the degree of curvature. That is, the definition of the degree of curvature is an angle, the angle, which is, this subtended angle, the angle, maybe delta, subtended by 100 feet of arc. The angle subtended by 100 feet of arc. And if you're given this, you can solve the curve. You'll know every part, you can figure out every part of the curve knowing the degree of curvature. Okay, so in the next video, I'm going to start giving equations for each part of the curve. I will see you in the next video.